All right, hi folks, this is Larry Mussolino. I'm recording a video for the Module 5 homework in STAT412. I wanted to talk a little bit about working with sample means and also using Excel to help out with some calculations. So let me come here to a typical homework problem. This is question number 3, and it says the length in time that 10 patients waited in a doctor's office are given by these data values. Treating the data as a random sample, find the range and the standard deviation. Now, the range is relatively straightforward. The range for a data set is just the max, subtract the min. So I can probably just do this by hand. I'm not going to use Excel for this. So I'm just going to scan these numbers looking for the max. That's the largest number. It looks like it's 18. And I'm going to look for the smallest number, the min. That looks like 3. So this answer just turns out to be 15. But usually the range is not the best measure of variation. I'm trying to really get an estimate of how spread out these numbers are. Well, the range is just using 2 numbers out of the whole data set, the largest and the smallest. It's not really taking into account all the other data values. So that's why the standard deviation is usually preferred. Standard deviation is giving us a measure of the spread of the data. Really, it's how far is the typical data value away from the mean? Well, the calculation for standard deviation is pretty messy, so I'd like to get Excel to do it for me. So one thing I'm going to do is come here and copy this data into Excel or copy it to the clipboard because I don't want to retype it. So I'm going to say copy to the clipboard. Now I could just do a copy and paste. So I'm doing a copy, and I'm coming over here to Excel and doing a paste, and here are the numbers copied. Now I can use a command in Excel to find the standard deviation of a sample, and that command is equals stdev.s. So that's standard deviation for a sample. And in parentheses, I have to tell Excel what cells are my data values sitting in. Well, here's cell A1 for the first data value, and here's cell A10 for the last data value. So what I would type in here is A1 colon A10. And Excel would automatically calculate the standard deviation. So let's do it. I'm just going to type in here equals stdev.s, whoops, stdev.s, parentheses A1 colon A10. And when I do that, notice how Excel is highlighting the numbers in blue to show me those are the data values I'm working with. And if I hit enter here, it looks like 5.10. So the standard deviation here turns out to be 5.10 rounded to 2 decimal places. All right, so using Excel, of course, is going to be a very good idea. In Module 5, you're going to be working on the midterm project where using Excel would be is required. All right, let me take a look at another example here. All right, here's another example. This is the tar contents in milligrams for 8 brands of cigarettes, and they're asking us here, what is the mean and the variance? Okay. All right, well, I'm going to go ahead and use Excel for this again. For the mean, Excel has a command called equals average. And for the standard, for the variance, there's a command called var.s. We're going to assume this is the variance of a sample. All right, so I'm going to copy this data into Excel and let Excel do the work here for us. So let me copy this data into Excel. I'll copy it to the clipboard. And then I can copy it over here into Excel. Okay. And I'm going to come here and say equals average. And in our case, it's going to be C1 colon C8. Right, that's where our data values are sitting. Excel highlights them in blue. And it looks like we're coming up with 11.91 rounded to 2 decimal places. And let's do the variance. I'm going to type in equals var.s. Here's a little shortcut. rather than typing in the names of the cells, I could just come here with my mouse and highlight the cells of interest, and Excel will automatically populate the cell numbers. In this case, it was C1 to C8. So here's the variance. It looks like it's 8.51. So we found out the mean was 11.91, and this variance was 8.5. All right, so Excel will make these kinds of questions quick and efficient to do this calculation. All right, let me get another example here. All right, folks, let's take a look at an example here. This is question 7. And this question is asking you to think about a sampling distribution of random samples. So what this is, we're analyzing the sample means in this example. And the sample size is 81. Let me give you a quick example here. Let's say I'm going to take a group of a sample of 81 people, and I want to know their average age. So let's say I take a sample. Let's call this sample number 1. I take 81 people and I find the average age. The average age turns out to be, let's say 34 years old. And I'm going to take another sample of 81. And now the sample mean turns out to be 37. I'm going to take another sample of 81 people. Now the average age turns out to be 32 years old, etc. So I'm going to continue to take samples like this, and I want to know what is the mean and standard deviation of these X bars. These X bars are the sample means. So I want to know what is the mean and standard deviation of these X bar numbers. Well, for the standard deviation of the sample means, we write it as sigma X bar like this. This is equal to the population standard deviation divided by the square root of the sample size. This is an important formula we're going to use here in Module 5. All right, well, let me go to the first part of this. They're telling me the sample size is 81, and they're also telling me that the mean of the sampling distribution is 6. Well, that means sigma sub X bar is 6. So let me plug in this number they're telling me is 6. The population standard deviation we don't know. The square root of the sample size is the square root of 81. But the square root of 81 is 9. So this is 6 equals population standard deviation over 9. I'll multiply both sides of this equation by 9. So the population standard deviation looks like 9 times 6, which is 54. All right, let's go to the second part of the question. It says, how large should the sample size be if the standard deviation is going to be reduced to 4.5? So now what they want to know is, what should the sample size be? I'm going to use the same formula again. But now n is the unknown quantity. So the standard deviation of the sample means is to be reduced to 45. The population standard deviation is 54, and we want to figure out the sample size n. All right, so this means the square root of n is 54 divided by 4.5. And that means the square root of n is 12. And of course, I'm just going to square both sides here to get n. If I square both sides, n equals 140. So it's telling me the sample size should be increased to 144. Okay. Let me take a look at another example here. All right, folks, let me take a look at another example here from the Module 5 homework. This is question number 12. And it says here, it says, if a certain machine makes electrical resistors having a mean resistance of 40 and a standard deviation of 2, actually, I'm going to use the population mean here, because I think what's being implied is a population mean, and the population standard deviation is 2. All right, I'm going to take a random sample of 36. And it says, what is the probability that this sample of 36 will have a combined resistance of 1476 ohms? Well, first, let me find the mean of the sample means. The mean of the sample means is the same as the population mean, which is 40 in our example. The standard deviation of the sample means is calculated by taking the population standard deviation divided by the square root of the sample size. In our case, the population standard deviation was 2. The sample size was 36, so I'm going to work this out to be 2 divided by the square root of 36. That's 2 over 6, and that's 1/3. All right, here's the question. Find the probability that a sample of 36 of these resistors will have a combined resistance of 1476. Well, what that would mean is each resistor, if I take the 1476 combined and divide it by each one of the 36 resistors, it means I'm looking for a resistance of 41 ohms per resistor. So here's what I'm trying to find then. Here is a plot of the sample means. The mean is 40. I want to find the probability of more than 41 ohms. So I'm looking to find this area to the right of 41. Well, to make this a little easier, I'm going to go to an Excel workbook that finds the area under the normal curve. You could use these tables, but to use those tables, you have to convert to z-scores, and you could definitely do it that way. But I'm going to use this Excel calculator that is posted in course announcements. All right, so I'm going to come here. I'm going to enter the mean of 40. The standard deviation is 1/3. I'm entering that as 0.3333. The x value is 41. We want to know the area to the right of this x value. Well, according to this calculator, it's 0.0013. So 0.0013 is the result on this. All right, folks, hope this is helpful as you're working in the Module 5 homework.